Alright, grade 12, we're looking at an organic chemistry question where they give us a flow diagram and we need to identify the type of reactions that take place and write balance equations as well. So looking at this question, it comes from the Free State, September 2016, the trial examination that was written in Free State in 2016. And this is a very popular type of question where we get a flow diagram and we need to make sense of it. So we can see here that there are arrows showing reaction A, B, C, and they give us a whole lot of compounds. So where do we start? Firstly, we look at a place on the flow diagram where we have a lot of information. So in this case, it would be compound X. So we can see for compound X, they've given us the condensed structural formula. So now what I'm going to do is I'm going to draw this. So X, if I draw it, it's CH3. So we have a carbon. And I'm just going to take that out. Okay, so we have a CH3. That is how we would draw it. Remember, every carbon can accommodate a maximum of 4 bonds. And so we look back at X, there's a CH3, then CH. So there's a carbon bonded to a hydrogen. And then there's a chlorine and a CH3 again. So this is compound X. We've drawn it. We've drawn the structural formula. And they show us this arrow going downwards. They call this reaction B. And they tell us that an alkene is formed. And they show us that it reacts with concentrated KOH. And an alkene is going to form. So quite a lot of information has been given here. So the first thing we look at is the concentrated KOH. So we now have a concentrated base. And this is a very important reaction condition. In fact, this is the highlight. This is the tip that they give us. Concentrated base means that elimination will take place. So this is something we need to learn, that when we see concentrated strong bases such as KOH or a concentrated strong base such as NaOH, then elimination will occur. So if I look at this reaction, I need to do an elimination. So the first thing that would be eliminated is the atom that does not belong there, and that would be chlorine. So we know that the chlorine would be removed. But chlorine is not removed on its own. A hydrogen will join it. So it could be a hydrogen from the right-hand side, or it could be a hydrogen from the left-hand side. And usually when a hydrogen is removed, it is removed from the carbon which has the least number of hydrogens attached to it. So again, when a hydrogen is removed, it is removed from a carbon which has the least number of hydrogens attached to it. So if I look here, this carbon has 3 hydrogens and this carbon has 3 hydrogens as well. Both have an equal number. So it would not matter which side we remove from. The middle carbon has already let go of a chlorine. It's already removed a chlorine. So this hydrogen here remains. So what I can say is this chlorine and this hydrogen are removed. So now when I draw my alkene, 1, 2, 3, our main chain still has 3 carbons. We've removed a chlorine from number 2 and from number 1. So in between number 2 and number 1, a double bond will form. Remember, one of the properties of elimination is that a double bond forms. So where does the double bond form? It would form between the 2 carbons where we removed the hydrogen and the chlorine. So that would be carbon number 2 and carbon number 1. And then we give each of our carbons their 4 bonds. So each carbon accommodates a maximum of 4 bonds. And we draw in our original atom. So the first carbon had 3 hydrogens. And then the second carbon had a hydrogen and a chlorine. But remember, the chlorine has been eliminated. And the last one had 3 and the 1 was eliminated. So that is what we are left with. And if we name our alkene 1, 2, 3 in the main chain, so parent name is prop. We see the double bond, so we know that there's going to be a name ending in "-ine", and the double bond is the number 1. So prop-1-ine. That is the name of this alkene. And the other product that would form would be HCl, because remember, the hydrogen and the chlorine were eliminated. So this is your balanced equation for reaction B. And this could earn you up to 4 marks. So usually they would give you a mark for each of your compounds and a mark for the balancing. So I hope this makes sense and you understand elimination a little bit better. Let's have a look at the next reaction. Let's follow through here where they show us that the alkene now undergoes reaction D and an alkane is formed. So now we are starting off with prop-1-ine. So let me draw prop-1-ine again. So because we found the central compound, so we know this is prop-1-ine, it's now going to be easier for us to work with all the other reactions. So remember, we are doing reaction D now. So we start off with an alkene plus hydrogen and an alkane is formed. So firstly, the type of reaction that occurs, we know that the type of reaction that occurs is an addition reaction. And how do we know this? Is because if we're starting off with an alkene and we're ending off with an alkane, then this tells us that the double bond breaks. And this is one of the main features of addition reaction, that the double bond would break. So what I would do is I would start off with my original compound with 3 carbons in the main chain, and we will break this double bond. So to break it, we would give each carbon 4 bonds. Now if I fill in all original hydrogens, on the first carbon I have 3 hydrogens. On the second carbon we only had 1 hydrogen, so we draw that in, and on the last carbon we had 2. So now you can see that by breaking that double bond, two spaces have opened up here. So there's space now for 2 atoms, and we are adding H2. So a hydrogen would form there, and a hydrogen would bond here, and a hydrogen would bond there. And we're now left with propane, because single bonds, name ends in -ane, and the main chain has 3 carbons, propane. Okay, so looking now at reaction C, we can see that they're showing us this arrow. So reaction C occurs and the alkene prop-1-ine is formed. So I've just set this up here. Here's reaction C in blue at the top. So here's my prop-1-ine, the alkene at the center, and it undergoes reaction C, but it starts off with a secondary alcohol. So now we're going to need to identify this secondary alcohol. So firstly, we can see that we are ending up with prop-1-ine. So that tells me that my alcohol is also prop, meaning my alcohol also has 3 carbons in the main chain. Now what do we know about alcohols? Firstly, we know that alcohols have single bonds between their carbons. So I can fill in making sure that every carbon gets 4 bonds. And secondly, we know that alcohols have the OH group, and the OH group is known as the hydroxyl. So they told us, they gave us a clue, they said it needs to be a secondary alcohol. So this indicates to us that the OH group is on the middle carbon. And how do we get that? From our definition of secondary alcohol, a secondary alcohol is an alcohol in which the carbon, which is attached to the OH group, so here's that carbon, this is the carbon attached to the OH group, it is attached directly to 2 other carbons. So you can see on the right hand side there's a carbon, and on the left hand side there's a carbon. Now if I had drawn it like this, and I put the OH group on the first carbon, then the carbon that holds the OH group, that's this one, is only attached to 1 other carbon. So that would be incorrect. This would have been a primary alcohol. And the question clearly said they want a secondary alcohol. So that is how we know what our secondary alcohol is going to be. So we use the definition of alcohols to help, of primary, secondary, and tertiary alcohols to help us there. So this alcohol name is going to be propane, coming from propane. So 1, 2, 3 in the main chain, propane dash 2 dash all, and that is our secondary alcohol. Coming to the last reaction, so if I look here, they show us that the secondary alcohol undergoes reaction A and compound Y is formed. So I've just drawn Y in here. It was 1, 2, 3 again, so it was propane, but hanging from this propane there's a chloro on number 2. So the name of this was 2-chloropropane. And they said that we started off with a secondary alcohol. So this is what we started off with. So if you look at this, you can see that the only difference between them is that the middle carbon has an OH group, and here the middle carbon has a chloro. The single bonds remain, so it's still an alkane. And this is our clue that they just swapped places. The OH went into the place where the chloro was on the second carbon. And this is known as a substitution reaction. And a chloro was substituted, a halogen was substituted. So we call this halogenation. And if we wanted the reaction conditions for this, so we said this was halogenation, a type of substitution reaction. And the reaction conditions for substitution is a dilute weak base. A dilute strong base. So this time we could use dilute KOH. Remember earlier we said that we would use concentrated KOH for elimination or concentrated NaOH for elimination. Here we would use dilute for substitution. So I hope that this made sense to you. I hope that you feel more confident in flow diagrams and organic chemistry. Keep practicing, and if this video helped you, please like, subscribe so that you don't miss future videos, and share this video with your friends so that more learners can benefit from these lessons.